Hello everyone. In this video, we are going to discuss about snake game using reinforcement learning. My teammate is Pradeep. Project objectives are the agent here is a snake, which will play the whole game in a grid of 16 by 16. Uh, Here, the snake can move in four different directions, like up, down, left, and right. Snake gets rewarded for eating a fruit. The game ends when the snake hits the wall or hits itself. For every fruit snake eats, its length increases by one, and a new fruit is generated at a random unequipped space. The goal of this project is to train an AI agent to perform well-devised snake game and get obtain maximum length at the end of the game. Uh, to complete this project, we are using different approaches like reinforcement learning and DeepQ learning. We are using tools like Python 3.6 version, and for IDE, we are using Python community version. Uh, and also, we are using some Python libraries like Pygame and PyTorch, where Pygame is a cross-platform set of Python modules designed for writing video games. It includes computer graphics and sound libraries designed to be used in programming languages like Python. Whereas PyTorch is also an open source machine learning library based on the Torch library, used for applications such as computer vision, natural language processing, primarily developed by Facebook's AI Research Lab. Reinforcement learning is a machine learning training method based on rewarding desired behaviors uh, and also punishing the undesired ones. In general, a reinforcement learning agent is able to perceive and interpret its environment, take actions, and learn through trial and error. Uh, Deep pure learning is a model-free reinforcement learning algorithm. To learn the value of an action in a particular state, it does not require a model of the environment. Hence, it is called model free, and it can interpret its environment, take actions, and learn through trial and error. Uh, and it can handle problems with stochastic transactions and rewards without requiring requiring adaptations. Uh, Deep Q learning is based on Markov decision process. Q learning finds an optimal policy in same as in sense of maximizing the expected value of the total reward over any successive steps. Starting from the current state, Q-learning can identify an optimal action selection policy for any given FMDP. Given infinite explanation time and a partly random policy, Q refers to the function that algorithm computes the expected rewards for an action takes in the given state. Deliverables are we are going to provide a Python code walkthrough, and also a YouTube video link is provided of this recording. GitHub link, where in GitHub link it consists of source and YouTube video, and also a documentation readme.md file, and also PPT that is being presented now. Now we'll go through the code walkthrough. Uh, the okay in qlearning.py we are using basic we are using a snake as an inheritance class for snake game. The basic inputs are written here. We'll start by defining the values. We'll start by defining the values. In our board dimensions is the size of the board. 16 by 16 is a very convenient one for Q learning. So we choose to use 16 as a board dimension. Number of states are 2 power of 8 means at a particular point, the snake has 2 power of 8 states for it. Number of actions are only 4. At a particular point, the snake can only move in 4 different directions. So we are choosing the number of actions as 4. And now q equal to zeros of 0 array with an input of number of states and number of actions, which can be formed as which is a matrix with number of states as m and the number of actions as n. Learning rate we are not using in Q learning. We'll use the learning rate for reinforcement learning. Gamma is the discount rate where we are using as 0.8. Exploration in training games is 0.2 for Q learning. Number of episodes is used for training an agent. Here I'm using 10,001 as a number for training the agent. It can vary depending upon your user choice. Now the QS is equal to is a three-dimensional array of zeros with number of episodes, number of states, and number of actions. Uh, these are zero matrices initially. Whenever the agent is playing game, the matrix gets updated. So it learns how to go in the future paths. So we are storing the values of the previous games in Q and QS. Uh, so we are iterating over the number of episodes. Range of episodes means range is 10,001. So we are iterating over the episode. We are going to play the game for 10,001. So snake game here, game equal to snake game of both dimensions we are passing, where snake game is an inheritance class from the snake.py, which we are using, which is our base environment for playing the game. Okay, state is equal to game dot where game equal to snake game both dimensions dot calculate state num. Calculate state num is an inbuilt function for in a class snake game where it gives an integer for a particular state. So it returns the integer value for a particular state for the game one. Initially, the game over is false, and now the score is a 0. While not in game over, initially it will be it will not be in game over. If it isn't game over, it will exit and it will go to the queue state action. Okay. If it is not in game over, then it will choose a random value between 0.0 to 1. If it is less than exploration value, uh, which is 0.2, then action will takes place. Action will be assigned with random value of 0 to 3. Hence, uh, action is equal to argmax of possible queues, where possible queues uh, is an array with state as index. State as the index we are passing, where state is an integer value which we got from the calculate state now. Now game dot make move returns us 4 different values. Make move is an inherent function in uh, snake game, which returns us new state, reward, game status, and score. Game status is a boolean value. Game over is a boolean value. It is true or false. Reward can be +2, -2, and the score is the depends upon the number of fruits eaten by the snake. A new state is the next state the snake is going to attain using Markov detection decision making process in Q learning. The Q state and action. Q is a matrix for a state and array of state and action. We are going to find the value of state and action. So with the Q learning formula, reward plus gamma into NP max of Q of new state as an index. This is for Q learning. Line which is the commented one is the for Q learning with reinforcement learning, where we are adding the queue of state comma action initial value also to the learning rate of the deep learning. And also we are assigning state into new state. So this loop goes on. Okay, we are also copying the QS of index episode to new queue. If episode percentage is zero, then average length episode percentage is zero, then basically the game is over for a particular episode. So average length and length are calculated using evaluate score. Evaluate score can be found here, which takes input as Q, broad dimensions, and num runs. Runs for the game for a specific number of runs given a specific Q matrix. Cutoff is maximum is 100. If it is 100, it will exit the game. Yeah, it would also do use some make move functions and other functions, counter functions to find the integer value of the next state. And also it returns the average scores, and it will return the average scores and score. It returns the average score and score. Okay. In this way, the loop iteration goes on for 10,001 games. All the values have been stored in the Q matrices. Okay. If you want to plot these games for the final submissions, we are using plot episodes. So here I'm plotting 0 at episode 200, it's episode 400, and I'm also plotting 10,001 episode to check the differences by check the differences. We are using an enumerate function to plot all the graphs in a single photo. And also we are planning to record a video of the game, so we are using an animate function which saves an saves the video to a file. Let me run the game and show how Q-learning is working. See, it is iterating over that function, and it is generating the output average snake length. Yeah. No, it is at 5. It is iterating over with a gap of 100, where we know the cutoff is 100 here. So it is updating with the cutoff of 100 everywhere. We're getting the average length. You can see that the average length is increasing. At a certain point, the average length is constant between 25 to 30. Yeah, that is the maximum value that the Q-learning agent can approach. Okay, and now we'll watch a video of the games played by the agent, Q-learning agent. Okay, in the episode 10, the length is 20 and it is going on. Okay. Okay. This is the Python code we are talking about. YouTube video will be presented for this recording, and also GitHub repo. Evaluation methodologies. The goal of the project is to give an idea how reinforcement learning can be applied for a snake game. As you have seen that as the number of episodes increases, the average length of the snake is increasing, which is attained by reinforcement learning and Q learning. Thank you so much. I'm going to stop the recording.